Hello, everyone. This is Ahmed Riyad, PhD. I'm a candidate for the position of IT Analyst Principal GIS, Solano County, California. And for my technical demonstration, I have chosen my first topic as Advanced Spatial Analysis and Modeling. So for Solano County, one of the main hazards, natural hazards that Solano County faces is wildfires. Fire exposure is pretty common. And just last year have seen in California fire that how devastating wildfire can be, particularly in California. So it's important to have an idea like where people are living, the majority of the density, and where the flood hazards and the risks are. To keep that in mind, the goal of this task will be to find out on a microgrid level, 10 square kilometer level, that where the fire exposure is and where people are mostly living by, and create a map out of it that would demonstrate my advanced spatial analysis techniques and also at the same time my visualization, which I will be demonstrating in the next part. So I have preloaded the data in the ArcPro project, so it saves me some time. I will just quickly explain what data that I have loaded. I have loaded the county boundary of Solano, and I have downloaded data from the pre-GIS portal, the Solano County website, and then I have loaded the California fire hazard exposure data that I will be clipping into the Solano County boundary so that I don't have any access or unnecessary information. And I have also loaded the California Census 2020 information so that I can have the demographic or population data necessary. Before I go into the grids, I will just process this two layers into the Solano County boundary. So for that, I will use the clip tool, and before the clip tool, it has been very successful, has been very popular in terms of like geoprocessing tools, but now it will be retiring pretty soon. And there is another tool that's available that's called pairwise clip. They're pretty much the same tool, does the same job, only pairwise clip is more efficient as it uses optimum level of coarse necessary for this job. So even if you need to do multiple clipping at the same time, it can analyze and understand it properly. So I'm going to use the pairwise clip and make sure that it's in batch mode so that I don't have to do it on like two clips separately. I can do it together. So the two layers that I need to clip, this is the California census data, and this is the fire exposure data. And the clip portion, we want it within the county boundary. So I'm going to set to that. And the name, I prefer changing the names when this is done so that I can name it the way that I want. So I will let it run and clip it to the Solano County portion. Okay, so the clipping has been successfully completed, and now I'm gonna turn off the whole California layer so that it avoids all the unnecessary information or the data. We only need the Solano County portion. And another thing that I always make sure I also tell my people or the GIS analysts that work for me that always make sure that every layer that you are working on, whenever you do a data analysis, that they are on the same projection system before you even do anything else, because it saves a lot of hassle and it's the best practice. So this is what I'm going to do. I have checked already that the county boundary information is in NAT 83 projection system. I'm going to double check and go to the source and special reference. It is NAT 83 right here. So I'm going to make sure that the rest of the layers are also in that exact projection. So just to make sure, I'm going to batch project this too, because now there are only two layers, but it could be that I'm dealing with multiple layers, 5, 10, hundreds, and I cannot just manually go to each of the layers and then fix the projection. So I'm going to use the batch projection, the input raster. Sorry, that's Project Raster. It's the wrong tool. I'm gonna use the batch project. So the input feature class or the data set are gonna be the pairwise. I'm gonna just select it from here. These are the two that I will output here, and the output workspace, I'm gonna select this geodatabase that I have already created, the output coordinate system, make sure it matches with the county boundary, and then I'm gonna let it run. Once the projection system is matched, then I'm going to proceed with the rest of the analysis and make sure that the rename and the name of the databases and layers make sense. So now we are on the same page. Make sure that we are using the one that matches the projection, and these are not the ones because when the batch project produces the new updated layers, they are not automatically put into the map. We have to bring them from the geodatabase. As you can see, there is a copy of the ones that we are using. So I'm gonna get rid of this two and bring this copied ones or recreated ones so that I'm making sure that I'm using the reprojected ones. So I have brought them back. Um, Now I have these layers, but the names are funky and we don't want that. We want a clean name that's easily understandable. And if someone else from another team or group are working, they can understand what exactly is going on with these layers. And these are fire exposure Solano County. So that would do. That would do for this. And for this, I'm gonna call it census demography Solano. So now we know this is the census layer and this is the fire exposure layer. And the next thing, the next step of the process would be to create a fishnet grid that I have already created. And I'm gonna just to save time, quickly show exactly how I did. So I use the fishnet create fishnet tool here, and I made sure that the extent of this is within the county boundary and it's not crossing that. And the size of the cell, the size of the grids, I'm using 10 square kilometers. So I'm using 10,000 as value because the units are in meters, as in net 83 projection system is gonna be. So this is what the output is. Since it's in the bottom, I'm gonna put it on the top so we can see the grids. So these are the grids. And the idea is to understand the risk of the fire exposure per grid. And also, I am going to add the number of people or the population density into each of these grids and the fire risk incorporated in the grid and create a bivariate map and show it right here. So for that, the first thing that I'm gonna do is do spatial join. And do a spatial join. Target is gonna be the Solana grid clipped and one-on-one, and the output and the input feature is gonna be the fire exposure Solano, um, and also the census demography. So these are the things that I will be adding and make sure that they come up. So then I'm gonna create and keep only those that are necessary and remove those that are I don't want. So and then I will decide which fields to keep and which fields to remove. So we have a spatial joined grid right now, fishnet grid, and this fishnet grid attribute table should have both the information of fire risk, fire exposure, and the population, and create the map. I'm going to create the bivariate colors. The field 1 is going to be fire exposure Solano, and I prefer to normalize. I prefer to normalize, but for now, I will just keep it that way and see how exactly that shows. So population 2020, that's we also have population 2025, so let's use that. Okay, so we do have a good result that's showing that which are the areas that have high fire exposure and also high population. So if we find these dark colors, this navy blue colors right here, these are the ones that has higher population and also high fire risk at the same time. And expected this whole area right here is within the low zone because not much fire exposure in those zones, and these are the areas that we need to be careful about. So this is what the spatial analysis is, and if we take a look at the cartography part, I will talk about in my next topic. So I think we have been able to achieve what we wanted here. The planners or the policymakers, the decision makers are going to have a look at this map and be able to quickly understand that these are the areas that we need to focus more because there are more people living in here. And at the same time, they are under threat. And about the cartographic visualization part, I will be talking about it in the next video. Thank you.